Okay, so we're starting with our next video, structures of the atom. You know that opposite charges attract while like charges repel. So if we look at the protons and the electrons, protons are positive, electrons are negative. So protons and electrons will attract each other because opposites attract, but if a proton's next to a proton, it tends to repel, or an electron's next to an electron, it will repel. So inside the atom, we've got several different things. We've got a proton. A proton, common symbol, is a lowercase p with a positive. Its charge is a +1. It has a mass, actual mass, of 1.6727 times 10 to the negative 24, which is very, very small. So instead of using that, we use atomic mass units, and its atomic mass unit would be 1. And it is located inside the nucleus. Our next subatomic particle would be a neutron. A neutron is symboled by lowercase n with a 0 superscript, and it has, of course, neutral, no charge. Its mass is really close to that of a proton, so we're going to give it an atomic mass unit of 1. Its actual mass is the same as a proton to 3 significant figures. At the 3 significant figure mark, it changes a little bit. And it is also found in the nucleus. It sort of separates the protons so they don't repel each other. Electrons, I like this. If there's a negative experience, you call 911, right? If you have a negative experience. Well, 9.11 times 10 to the negative 28 is what an electron weighs. You'll notice it's 4 places smaller than a proton or a neutron. So an electron, whoops, that should be not a P plus, that should be an E minus. Let's fix that really quickly. This should not be this. It should be E with a minus, lowercase e. All right, going forward, it has a -1 charge. Its mass overall is considered very small, 1/1840 or 1/2000 or 0.005 of the mass of a proton or a neutron. And you can see where that comes in right there. A neutron is basically a proton plus an electron. And it is found orbiting the nucleus. Okay, so the structure of the atom. When we're looking at the periodic table, that number at the top, whatever number it is on the periodic table, that is its atomic number. That tells me the number of protons in the nucleus. Every atom of a given element has the same number of protons in the nucleus. Different elements have different atomic numbers, so that's important. So if I have a hydrogen, it has 1 proton. If I have a calcium, it has 20. If I have aluminum, it has 13 protons. I'll always know the number of protons. And in a neutral atom, it has no charge. So remember, protons are positive, so I have to have the same number of negative electrons. So whatever the atomic number is the number of protons and electrons in a neutral atom, and that's important to note. It has to be neutral. So when we work with isotopes, we have a mass number that we put on top. This is called a nuclear symbol. This mass number is the number of protons plus the number of neutrons. And the atomic number is put down at the bottom. Now, oftentimes they don't write this bottom number because you should be able to get it from the element symbol here that is noticed as X. So let's talk a little bit about isotopes. Isotopes are atoms of the same element, but they have different number of neutrons. So the mass changes. The identity, the protons, does not change, but the number of neutrons does. So as I'm looking at this one, a mass number of 35, an atomic number of 17, I can quickly find out that the number of protons is 17 and the number of electrons is 17. To get the number of neutrons, I'm going to take 35 minus 17, and that gives me 18 for the number of neutrons. If I'm looking at this mass over here where I have 37 over 17, I still have the number of protons and electrons the same at 17. But the number of neutrons has changed because I'm going to take 37 minus 17 to get to the 20. So their mass has changed, but the identity hasn't. I sort of relate this to at Christmas time, after all that yummy, yummy, yummy food in January, my mass is not the same as it is in the summer. But I'm still me. So I still have my identity. But my mass has changed. Okay, so take that as you will. So atomic weight, that's what's listed right here on the bottom of the periodic table element block, is actually an average of all the different occurring isotopes of that element. So it's a weighted average, and we'll be doing a lab, if you haven't already, on serialiums to sort of help you understand how that works. There are many different isotopes of carbon. Some are stable, some are not. Radioactive carbon-14 we use to date things. And you can see the difference. The protons are the same, the electrons would be the same, but the neutrons are changing. And if you look at the overall mass of carbon, if we go back here, it's 12.011. So we have more carbon 12s than we have carbon 13s and 14s. So we have to actually take the mass times the percent plus the mass times the percent plus the mass times the percent to get the number that's on the periodic table. So let's take a minute and look at some examples here where we can quickly take and find the numbers. So first of all, if they give you a symbol that is not complete, like 1 and 2, I want you to complete it. So if we look for cobalt on the periodic table, and we find it, it is in the sunken area at the top, it's number 27. We're going to put 27 down here underneath. Then I can really quickly say, oh, there's 27 protons and 27 electrons, but in order to get the number of neutrons, I've got to go 60 minus 27. That will give me 33. That 60 is my mass number. Okay, so I'm going to pause the video. You pause the video, quickly do this, and we'll come back. All right, we are back. I'm going to really quickly put the answers up for you, and hopefully you did really well. I'm actually going to stop it, put the answers up, and then you can look at them all at once, so you don't have to watch me write them up. I decided to come back because I hit this number 3 and I forgot to tell you about the charge. Remember that the first two are neutral, so they don't have a charge. So protons and electrons are the same. Protons always have to be what's given. So it's going to be 16. The electrons are what can change to give me a charge. Now remember, protons are positive, electrons are negative, and neutrons are neutral. So if I'm ending up with a -2 charge, then I have 2 more electrons than the protons. So I'm going to have 18 here. I'm still going to take my mass number, which is 34, minus from 16. So that would be, what, 28? I'm doing this in my head, so I'm hoping that's correct. Next one, you're going to have 40 protons. And now you have a +2, so you're going to have 2 more protons than you have electrons. So the electrons here will be 38. My mass number is still 91. I'm going to take 91 minus 40 to get 51 for my neutrons. Now the bottom two are written a little bit different. This is hyphen notation instead of nuclear notation, but you're still going to do the same thing. They've told you what element it is, so you can figure out what the atomic number is. That dash whatever, that is your mass number. So I'm going to put those in right over here right away. And then I'm going to look on the periodic table, and my pen is not working over here. That's supposed to be a 40. And silicon is number 14. It doesn't have a charge, so number of electrons are the same. I'm going to take 28 minus 14, and I still get 14. That was nice. Argon, 18 on the periodic table. It's a noble gas. I don't have a charge, so I'm going to have 18 electrons. And 40 minus 18 is 22. All right. Hopefully you got all those. Now, we're going to write the symbols now. So if I have a copper atom with a mass of 64. So first of all, I'm going to look at copper. And copper is number 29 on the periodic table, and the symbol is Cu. So I'm going to go Cu, 29, and it said it had a mass number of 65. It didn't say any charge. So that's the nuclear notation. The other notation would be copper 65. Okay, I'm going to skip number 2 and do number 3, and then have you go back and do number 2 and 4. So potassium, if I look on the potassium, potassium is on the left-hand side of the periodic table. It is number 19, and it is symbolized by a capital K. So I would put the 19 down here. I would put the 41 up here, but it has a +1 charge, so I'm going to put a +1. So to write the other symbol, I would do potassium -41 with a +1 charge. Okay, I want you to do 2 and 4. I'll give you a few minutes. If you need to, pause the video and then come back when you're done. All right, I'm back with you. Let's see what you did. You should have had Ca here, and calcium on the periodic table is number 20, and you had atomic number of 40. And then calcium -40. On the bottom, chlorine is Cl. It is on the right-hand side. It's number 17, and mass number of 36, and it had a -1 charge. So you would go chlorine 36 with a -1. Okay, moving forward. Oh, let's go back just for a second. You'll notice that for the bottom 2, 3 and 4, it's much preferred to write it this way than it is to do the hyphen notation, just because it's much clearer. Okay, so make sure you write those in nuclear notation when they have a charge. All right, so as we're looking at this, when they talk about atomic mass units, basically in order to get atomic mass unit, we took carbon-12 because it's very stable and we could mass it, and we take 1/12 of that is the mass of an atomic mass unit, or a U. So that's how we got these from the previous slide, where it was 1840, or basically 0.005 as a difference. Okay, and you can see here Rutherford model of the atom, where it's more peach-like, showing the protons and neutrons in the center and the electrons on the outside. And we'll be doing a Bohr model of the atom, which is our snowflake, if we haven't already. All right, so determine the charge and mass in U of the nuclide made up of the following particles. So to find the mass, all you have to do is add the protons and the neutrons. So that's 11 U for this. And it didn't tell me anything about any electrons, so I'm going to have to say this is a +5 because there's no electrons to balance them. On the next one, 10 protons, 10 neutrons, so we've got 20 U. And the charge here, again, it didn't mention any electrons, so it's going to have a +10. On the bottom, we've got 5 protons, 4 neutrons. We ignore the electrons, remember, because they're so small. So we're going to have 9 U, but the electrons are now involved in the charge. The electrons and protons are not the same. I have more electrons than protons by 1, so the charge is a -1. Okay, hopefully that was fairly easy for you. Let's keep going. On this one right here, we're doing the relative mass of an atom. Oh, it looks like I better stop. So we're going to stop it and start on the next one. Sorry, I went over 3 minutes.